let's keep going. To talk about memory, let's talk a little bit of Freud. Freud is a great psychologist, even though sometimes the other psychologists don't like him. First, he looks very serious, and he always have his own theory. Like memory of traumatic events, Freud says sometimes you will repress those painful memories by burying those. Say those memories are way too painful, so you don't want to remember them, and your brain will help to repress them, so you don't remember. Like you went through some traumatic events, you don't remember anymore. And he's the father of psychoanalysis. So you have to use the psychoanalysis. They just keep talking, and eventually those memories will come back. And let's talk about losing memory. So that's now you live in this moment, and you can have the memory before, or you can lose the memory happens before, or you can have the lose the memory happen after. So if you lose the memory happen before, it's called the retrograde amnesia. So amnesia means losing memory. If you won't be able to form any memory after this traumatic events happens, it's called the anterograde amnesia. So you have the retrograde amnesia and anterograde amnesia. For the retrograde amnesia, you see that a lot in some soap opera TV shows. That woman, some traumatic events happens and she lost her memory. So she went to a new town and find a young, rich, handsome person who never exists in real life and fall in love with him. And his old lover go to the town and suddenly found her, and those two young, tall, handsome guys fight for her. And that's amnesia memory. So you lose the memory happens before the events happen. It actually happens. That's why we have the term called the retrograde amnesia. This tale about a lady. She forgot her memory. She has retrograde amnesia, and she went to a different town. Happened in Canada. And for some reason, she can use her expired U.S. passport, go to Canada, and they found her there. So that's the retrograde amnesia. And the anterograde amnesia, we have to talk about a very famous person. His name is H.M. And H.M. is a patient. He's not a doctor. He's not a scientist. He's a patient. He lived in the mid-20th century, and he has very serious epilepsy. Epilepsy is the neuron fire like crazy, create too much current. So his doctor decided to perform a surgery to remove the brain area fire like crazy to control epilepsy. And when you have epilepsy several times a day, it totally ruins your life because you could not do anything. You're just sitting in your room and so afraid epilepsy gonna come. Because think about when you drive on I-35, if epilepsy comes, and you can kill yourself and other people. So he agreed to receive the surgery. And it turned out the doctor find in the brain area, his brain, the areas that create a lot of current is hippocampus. So they remove both. You have two hippocampi, and they remove both hippocampi at pretty early age, at 30. So there's Nomo's brain, this hippocampus, and you can see his brain image. His hippocampus totally got removed. And after surgery, HM recovered, and his epilepsy is controlled, so he's pretty happy. But gradually he found pretty serious problem, like his nurse go to his room, and every time he would shake hand with the nurse, say, "Hey, nice to meet you, my name is HM." Until his nurse complained to him, say, "Well, we have already met for 1 week, why you treat me like you never met me before?" And that's when the HM realized he has a serious problem. He could not form any new memory. And he has pretty serious problem. He could not change job because he won't be able to remember his new job, and he won't be able to move because he won't be able to remember his new address, and he won't be able to make new friends because he go to sleep and next day he forget that person. He could not form any new memory after that day, and eventually he becomes so depressed, and he went back to that hospital. It's a medical school affiliated hospital. He said, okay, study me. So he turned himself into the guinea pig, and we studied him for about 40 years. And we know a lot of memory because of HM. And that's why in every textbook, psychology, biology, neuroscience, anatomy, physiology, every time we talk about memory, we talk about HM. And he died a few years ago. We call him HM because when this textbook was written, he was still alive. And a few years ago, when I listened to NPR, they talk about HM died. It's Henry Mollison. And he died at a pretty old age. And he stood, before he died, he stood in front of the mirror. And he could not recognize that old person image is him, because he only remembered his young image when he was 30. So that's HM. And it turned out it's not HM could not learn anything after surgery. He still learned something. And that's an experiment done by this doctor. And this doctor will put a needle in the hand. In the hospital, they have a lot of needle. And he will shake hands with the patient, not HM. The other patient got hippocampi removed. And now the patient got very angry. The patient will say, I want to sue you. But the patients could not form new memory. So after the patient went back, slept, and the next day she forgot. So she never come back and sue the doctor. And the interesting thing is the next week when the patient come back, when the doctor moved the hand out, and the patient could not remember what happened, but the patient refused to shake hands with the doctor. So it turned out we have different kind of memory. That's how we identify we have different kind of memory. Even though the patient lose certain kind of memory, they could not remember the whole events, but they still have other kind of memory. And HM actually can do something, can learn something. So that's the task they ask the HM to do. So they have to block the view. They use the mirror, the feedback. So the HM have to draw the line between those two stars. So it's not easy because you have to look at the mirror and train your hand. And every time you draw out of the stars, you create the error. And you found, okay, learning, right? Learning curve. We talk about this in the learning part. And the number of errors significantly decrease. And after 2 months, the HM will say, why this task is so easy? It's almost perfect on the test. And that's so easy. But I never done it before, but actually have done it for about 2 months. He just could not remember the whole episodic memory. You lose that part. And because of HM, okay, we know the memory, we have two kinds of memory. What's impaired? Explicit. He could not explain the whole events. He did not remember he practiced it. But he has those implicit memory or procedure memory. He learned the procedure. And that's the memory we used to learn riding a bicycle, playing piano, swimming. That's this kind of memory, procedure memory. He still have it. And let's look at the hippocampus function. HM, he lose hippocampus. And we have the short-term memory. HM can form the short-term memory. He just won't be able to turn it into the long-term memory. So that process called consolidation. So what's the function of the hippocampus? It's not where you store your long-term memory. Apparently, he still have his long-term memory. Happens before the events. He just could not form any new one. So it's the consolidation process require hippocampus. And one more thing, these events, sleep help. So if you think about, okay, well, I'm going to take the test, I want to skip my sleep to study, actually your brain don't perform well because this process require a good sleep. So this tell you, okay, finally we know the hippocampus function. The hippocampus is for the explicit memory, and to turn the short-term into the long-term memory, and that's the brain area required. And biologists, those behaviorists, they study the memory. They use mice to do the experiment. They found the hippocampus is really associated with this kind of memory. They call it a spatial memory. They will put mice into this. They call it water maze. And mice's job is to swim. And in order to find there's a hidden stage. They are able to stand on the stage. And the mice at first, they need to swim, be able to find it. And it's difficult because it's somewhere, and they make the water, they add some dye, make the water, they could not see the stage. And they will swing around and eventually find the stage. Okay, they will stand here. And the next time you put them in, okay, they will swing and eventually accidentally find it. And they measure the time. And after they do it for 20 times, you put them in, they would directly go here and stand on the stage. And that's the indication of learning. And it turned out hippocampus is very important, critical for this kind of learning. Because in the mice, if they damage the hippocampi, and turn out they won't be able to learn this, they will keep swimming until they accidentally find it. So these kind of tasks are very pretty famous in learning and memory. They're called the water maze. So compare with learning and unlearned. If this mice is unlearned or his hippocampi damaged, the memory impaired, they will keep swimming until they randomly find the stage. Compare with the learned one, you put them into the water maze, they just directly go here, and if they could not find it, they will keep swimming around here until they find it, because they know, okay, the stage should be somewhere around here. So compare with the learned and unlearned, that's what they found. And there are some experiments, they try to find the smart pill and the pill to treat memory-related disease. They use the water maze. They give the animals the pill and they found, okay, if their learning improved, they say this medicine can help the learning and memory, like the medicine treats Alzheimer's disease. Or about 20 years ago, it's pretty hot topic. They claim they found the smart pill. You take a pill, you can become smarter. And it turned out that experiment stopped in the rodents stage. So after you try the rodent, you have to go to the primates. If it still works in primates, it will go to human study, and human study have 4 different stages, stage 1 to stage 4. So stage 1 with very small amount of subject till the stage 4, there's a big amount of subject. If it still works, you're gonna apply for the FDA approval. So this whole process to get a new medicine, it takes about 20 years. And that experiment I talk about, it stopped in the rodent stage. A lot of medicine in the medical field, they stop in the rodent stage because the primates and the rodents, they are very different. The primates' brain are very, very complicated. So a lot of medicines, antidepressants, I also study some new antidepressants. And every year there's a new medicine found, and they all stop in the rodent stage because when they apply to the primates, it just won't work. Okay, I talked too much. Let's take a short break.